Dear students, I am Dr. R. Sharada, Professor in the Department of Chemistry, Avinashalingam Institute for Home Science and Higher Education for Women, Coimbatore, Tamil Nadu. Hope you are all in the pink of health and I welcome you all to e-Pathshala. I am back with the concepts of sample size and its determination, principles of calculating sample size, and methods of estimating sample size. A good research study depends on a number of ingredients and sampling technique is one among them. In addition to the technique adopted by the researcher in selecting the sample for the research study, the sample size is often debated as a vital factor that makes the study meaningful. There is a notion that a large sample may make the study more robust, but there are counter arguments that large sample alone does not make the study effective, and so many other parameters of research should also be looked into. This chapter deals with the sample size considerations for various types of research designs, and before getting into the detailed descriptions on this, it is essential to review the sample selection concepts in the light of the vital factors which make the research better. These factors are as important as the sample size consideration too in a research. A good research study addresses the following key factors: clear objectives, research questions that can be effectively addressed, design of the study clearly linked to the objectives and research questions, sampling procedures, tools used in the study, clear definition and classifications of variables, data gathering procedures, hypothesis relevant for the study. The focus in the objectives has an impact on the sample selection too. In case the objective of the study is exploratory in nature, then selection of a large sample is inevitable, whereas the researcher working on a confirmatory research may work with a small sample too. The research questions of the study are linked to the hypothesis, and the divergent nature of the questions may also determine the sample requirement. The sample selection for the study depends on some of the factors mentioned, and therefore sample size should be viewed in conjunction with all vital parameters of research. The terms large sample and small sample are generally used in discussions on sample size, and one may ask whether the large or small can be quantified. In fact, quantification of these terms becomes difficult as they are research specific. For example, an experimental research may treat even 10 samples as large for a particular study, as working with every individual requires a lot of time and better controls as well. On the other hand, a researcher may consider even 50 samples as small if the research is aimed at finding out the opinions of students about objective type questions in examinations. 500 samples may also be considered small if a statewide survey of teachers is conducted about a revised curriculum. Therefore, the terms large and small samples used in this chapter and also in general should be viewed in the context of the specific topic under discussion. Now, let us discuss the various factors affecting sample size determination in detail. Sample size and variables. Assume that the researcher wants to use four variables, namely locality, that is rural, urban and suburban. Then type of management may be government or private. Type of school, secondary, primary, higher secondary. And gender, boys or girls, using stratified random sampling. And for this purpose, the researcher has to gather data from 36 subgroups as per the table. Let us also assume that the researcher wants at least 20 subjects for each subgroup, as he or she is interested in using sizable sample for applying parametric statistics. Analysis of this data reveals the complications involved in its selection itself, which are: as the researcher is interested in applying parametric statistics, he or she should ensure that the population of each of the subgroup is normally distributed. The variances among the subgroups are equal and each sample is independent of each other. It implies that the population of each subgroup should be fairly large enough so that the 20 students are randomly selected. As is evident, the type of statistical analysis proposed to be used also decides the size of the sample. The second one is that besides the statistical procedure, the number of variables and the levels within each variable too decide the sample size. In this research, the researcher uses 4 variables, and reduction of one variable will definitely decrease the number of subgroups, which may also warrant less number of samples. A review of related literature is of utmost importance to find out the interrelation between variables used in the study in order to use the right variables less in number instead of simply using more variables in the study. Sometimes analysis of the impacts of variables on the study might reveal that some variables have identical effects, in which case eliminating one among them will not alter the results of the study to a large extent. The levels within each variable too have impact on the sample size. For example, the variable locality has 3 levels, namely rural, urban and suburban. Reduction of one level by combining the 3 levels into 2 would have an impact on the sample size. The design after leaving out the variable suburban may be redesigned as shown in table 2. The type of schools too has 3 levels, and bringing this down to 2 levels may reduce the number of sample. It should be noted that the number of variables or the levels within the variables should not be altered simply for the sole purpose of reducing the sample size, but that can be done if the results are not going to be affected to a large extent. The design after leaving one of the levels higher secondary will be as shown in table 3, provided the sample size in each subgroup does not change. Having too many subgroups in the study may be good from the point of view of analysis, but gathering data from many such groups involves time and resources too. Therefore, the researcher should decide to what extent the resources and time allow data collection, and this has an impact on the sample size too. In summary, selection of the right kind of variables in the study will definitely have a bearing on the sample size, and this demands a thorough knowledge of the research area. A researcher who has an insight about the correlation between potential variables will be able to narrow down to a few but significant variables for the study instead of including too many variables. Now, let's move on to the effect of research design on the determination of sample size. The research design too has an impact on the sample size. Assume that the researcher is interested in doing an in-depth study about behavioral changes in children and uses single subject research or a time series analysis. For such studies, a few subjects are studied over a period of time. Here, the methodology should be robust as it deals with a small sample, and the data gathering should be meticulous as the researcher may also try to generalize patterns of behavioral changes based on few case studies. Some researchers may try to do a sample survey on specific issues, and for this a reasonable number of participants will be necessary. Survey research is not done with a small sample. Opinions on specific concepts, social issues, etc. can be studied when the sample is fairly large. Experimental studies do not involve a large sample, but better control of the experimental conditions is imperative to make the results effective. Experimental designs generally satisfy the following conditions. Two groups, experimental and control, are involved in the experimental research. The samples in both the experimental and control groups are randomly selected. Both groups are administered pre-test and post-test. The experimental group alone gets the treatment. These strict stipulations make the sample size fairly small as better controls are necessary. There are good experimental studies involving as low as 5 students which are reported in the literature, and therefore the researcher may work with less number of sampling units if the characteristics of the experimental design are satisfied. That's it with the research designs and its effect on sample size. We are now to consider sample size and the measurement tool of the study. The sample size of the research may be linked to the type of measurement tools used by the researcher too. For example, the interview method in a research may not involve a huge sample as it takes time and human resources. Some interviews may be conducted online, but in this method too, there is significant time and number of samples involved. In some other research, the investigator might use observation techniques to note the behavioral changes, and this type of research too may not involve a large sample. On the other hand, questionnaire, rating scale, inventories, etc., when used as measurement tools, may involve a large number of samples too. Some statistical analysis procedures which have implications on the size of the sample are analysis of variance, analysis of covariance, canonical correlation, and multiple regressions. So far, we have been listing down in detail the various factors that determine the size of the sample to a study. Now it's time to discuss the various principles that govern the calculation of sample size. Consequential research requires an understanding of the statistics that derive sample size decisions. Before you calculate a sample size, you need to determine a few things about the target population and the sample you need. The first one is the population size. First and foremost, a researcher needs to know how many subjects or units will fit into the demographic which forms the sample size. Margin of error, that is the confidence interval. There cannot be a sample of extreme accuracy or perfection. Hence, the researcher needs to decide how much error could be allowed for the sample mean to fall from the population mean. This is called the confidence interval. The common confidence interval is plus or minus 5. The confidence level is the level of confidence that denotes that the sample mean actually falls within the confidence intervals. The usual confidence levels are 90%, 95% and 99%. Standard of deviation refers to the variance we expect from the respondents. As it is before the survey, it's always safe to use 0.5 deviations, which is the most forgiving number and ensures that your sample will be large enough. With an idea on the various principles that administer the calculation of sample size, we now make it more informative with the idea of how to estimate a sample size. In order to calculate the sample size, it is required to have some idea of the results expected in a study. In general, the greater the variability in the outcome variable, the larger the sample size required to assess whether an observed effect is a true effect. On the other hand, the more effective a tested treatment is, the smaller the sample size needed to detect this positive or negative effect. Estimating the sample size for a trial requires 4 basic components. The first one, the type 1 error, that is alpha. Most research studies are usually performed in a sample from a population rather than in the whole study population. In research, we are testing hypotheses to determine whether particular samples differ from each other. On the one hand, the null hypothesis, that is S0, that the groups of subjects, samples that are being compared are not different, that is, they come from the same source population. The alternative hypothesis H1, on the other hand, hypothesizes that these groups are different and that therefore they seem to be drawn from different source populations. Sample size calculations are needed to define at what number of subjects it becomes quite unlikely that adding more subjects will change the conclusion. In the process of hypothesis testing, 2 fundamental errors can occur. These errors are called type 1 and type 2 errors. The type 1 error alpha measures the probability that given the null hypothesis H0, that the samples come from the same source population, the differences found are likely to happen. The power. Instead of a false positive conclusion, investigators can also draw a false negative conclusion. In such cases, they conclude that there is no difference between two groups or treatments when in reality there is. Or in other words, they falsely accept the null hypothesis that the compared samples come from the same source population. This is called a type 2 error, beta. Conventionally, the beta is set at a level of 0.20, meaning that the researcher desires a less than 20% chance of a false negative conclusion. For the calculation of the sample size, one needs to know the power of a study. The third one is the smallest effect of interest, which is the minimal difference between the studied groups that the investigator wishes to detect and is often referred to as the minimal relevant difference. For example, if body weight is the outcome of a trial, an investigator could choose a difference of 5 kg as the minimal relevant difference. In a trial with a binary outcome, for example, the effect of a nutrient on the development of a child, infant, whether yes or no, an investigator should estimate a relevant difference between the event rates in both treatment groups and could choose, for instance, a difference of 10% between the treatment group and the control group as minimal relevant difference. Finally, the sample size calculation is based on using the population variance, that is the variability of a given outcome variable, that is estimated by means of the standard deviation in case of a continuous outcome. Because the variance is usually an unknown quantity, investigators often use an estimate obtained from a pilot study or use information from a previously performed study. Let us take an example of the experimental study and see how the sample is calculated. As two groups are involved in the research, the test of significance is usually done by applying t-test. For applying t-test, the level of significance is important. The researcher may use 0.01 levels or 0.05 levels in the research. Let us assume that the researcher in this case takes 0.01 as the significance level. Also assume that the test administered for the experimental group works on the basis that the standard deviation is 12. Verification of the t-table reveals that 2.7 is the value required if the test is administered to about 45 cases with a significance level of 0.01. Assume that the estimated mean difference between the experimental and control group is 6. Then the sample size, that is the capital N, can be estimated by using the formula N, that is the capital N, is equal to 2 multiplied by standard deviation square multiplied by expected t value square divided by estimated mean difference square. Using the above formula, we get the estimated sample as follows. N is equal to 2 multiplied by 12 into 12 multiplied by 2.7 into 2.7 divided by 6 multiplied by 6. It comes around 53.84 or 54. This estimation works when the researcher takes full control of the independent, dependent and extraneous variables. Well, we have come to the end of this chapter. In this lesson, we have enumerated the importance of sample size in research, its determination, principle of calculating sample size and methods of estimating sample size. As you understand by now, the sample size for a research study depends on a number of parameters such as the nature of the research, objective, analysis technique, etc. All research studies may not warrant large sample, whereas adequate sample is inevitable when the researcher tries to make comparison between groups with the help of specific statistical procedures. In an experimental study, even small sample will work if control factors in the research are handled effectively. In applying parametric statistics, the researcher should ensure that the population of each of the subgroup is normally distributed, the variances among the subgroups are equal, and each sample is independent of each other, and these conditions determine the size of the sample. The confidence level used in a research also is a determining factor of sample size. The stricter confidence limits warrant better control of variables, and a large sample too, as more accuracy is needed for the effective generalization of the results into the population. We have also discussed methods using formula in deciding the sample size, but the researcher should not rely only on this technique and also take into account factors such as design, tools used in the study, variables used, type of statistical procedures used, etc. in deciding the sample size. I hope this lesson has given you adequate knowledge about this sample size for any specific research, and you will gain more experience when you start applying these techniques in your own research. I hope there was a better inception of the concept of sample size and its determination. I assume you all have a better understanding. Wish you people all luck and success. Thank you.